Now we're going to review our unit that started us off this semester, which was solving radical equations and different things we can do with functions. So when we're solving radical equations, we looked at mostly square root and cube root. The goal is to get your root by itself. So my goal here is to get my square root by itself. So my first step is to minus 2. So I get negative 3 square root of x plus 1 equals negative 12. Divide by negative 3, and I get square root of x plus 1 equals 4. And then, once the square root's by itself, we're going to square both sides to get rid of our square root. So x plus 1 equals 16, minus 1, so x equals 15. The next one is same idea, but we're going to have to cube it in a sec. So 2 cube root of x minus 4. We need to minus the 1. So we get 4. Still not by itself, so we're going to divide by 2. Equals 2. Then to get rid of something with a cube root, we're going to cube both sides. So x minus 4 equals 2 cubed is 8. Add 4 and x equals 12. So this next one, we're going to minus 1 and then divide by 4. So negative 8, divide by 4, I get square root of x minus 5 equals negative 2. Ding, ding, ding. Flashing lights. This is no solution because when I have a square root equal to a negative, I can't do that over real numbers. There's no square root of a real number that gives me negative 2. So I'm done with that problem. I don't want to keep going. Because technically we should be checking our answers for something called an extraneous solution. But you can also use my rule of thumb that you just check to see if it's negative when it's equal to the square root part. And you're good to go. So what about this next one? We have a little bit more stuff going on. So we still need to get our square root by itself. So I need to add 5, but now I have something I need to combine with. So I have x plus 3. Is my square root by itself? Yes. So my step is going to be to square both sides. So I get x minus 1 equals, however it is that y'all are at this point multiplying this out, x plus 3, x plus 3, so that's x squared, 3x, of course I didn't leave enough space in my box, and 9. So x squared plus 6x plus 9, and then we're going to move everything, I'm going to move everything to the right. So I get that 0 equals x squared plus 5x plus 10. And this is lovely because here we would usually be factoring what multiplies to 10 and adds to 5, but nothing multiplies to 10 and adds to 5, which means I would be reduced to quadratic formula, which I'm not going to put you through on this one. So this is so exciting that this worked out this way. Not really. But we're going to, deal with it. What you want to make sure you do, so you'd be able to factor this if I give it to you on a test. But we do quadratic formula, x equals opposite b plus or minus square root, blah, blah, blah. But we have to go back and check our answers. So what you want to make sure is that you don't have a square root, a negative under your square root when I plug things back in, and that I get something that makes sense. So I don't want to get like 5 equals 7. That's not true. We'll make sure to do one in class like that since I did a great job choosing that problem. Sorry. Alright, so after that we moved on to function combination, which meant we were just adding and subtracting a whole bunch of stuff. So you know how we do color coding. Okay, I have f of x, I have g of x, I have h of x. Okay, so if I want to do f of x plus g of x, it's just doing the red plus the blue. So x plus 2, red, plus 3x minus 1, blue. Done. Please don't do anything else, but please do put parentheses. So when I want to do the h minus g, I'm doing h, which is x squared minus 6, parentheses, okay, minus g of x is the blue, 3x minus 1, leave it, f over g, so that's red, x plus 2, over g of x is 3x minus 1. G over f of x would be blue 3x minus 1 over red x plus 2. F times g of x is going to be red times blue. Okay, the rest have numbers. So the thing I skipped over was domain. So my only restrictions for a domain are when I have a square root, and that's where what's underneath needs to be greater than or equal to 0, or when I have an x in the denominator, and then what's in the denominator cannot be equal to 0. So this first one, I don't have either of those two situations, so it's all real numbers. Same thing, all real numbers. Ding, 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 fraction. So for domain, I need 3x minus 1 cannot be 0, which means that x cannot be 1/3. Everything else is fine. Versus if I just flip the numerator and denominator, I have a fraction again, so x plus 2 cannot be 0, which means x cannot be -2. And last one is going to be all real numbers. I don't have either of my two situations. All right. So for the next set where we have numbers, I personally find it easier to split it up. So I'm going to find g of -2 and add f of -2 versus combine the functions and then plug in -2. So g of -2 is plugging in -2 for x, so 3 times -2 is -6, minus 1 is -7, plus f of -2, -2 plus 2 is 0, so this is -7. G of 3 times h of 3, not n of 3, that's ugly, sorry. G of 3, so 3 times 3 is 9, minus 1 is 8. H of 3, 3 squared is 9, plus 6 is 15. Yuck. So that's going to give me, let's see, I'm trying to do all these shortcut ways, 120. Then g of 4 minus f of 4. So g of 4, 12 minus 1 is 11. Minus f of 4, 4 plus 2 is 6, so this is 5. And then h of 1 over f of 1. So h of 1, 1 squared is 1, plus 6 is 7. Then 1 plus 2 is 3, so 7/3. Composition is when I put one function into the other function. So I'm going to do the same thing. I have and we got to use all my colors for this one. All right. So if I want g of h of x, that means my outside function is blue. So something squared plus 3. And the something I'm plugging in is h, which is my green function, so 2x minus 3. Hey, I did it. Okay, and what's my domain for that? I don't have either of my two situations, so it's all real numbers. And we have to also look at this inside function. So since my inside function had all real numbers, we're good. Now we're going to reverse the order, so I'm going to do h, 2 times something minus 3, and I'm going to plug in g of x, x squared plus 3. Once again, is my inside x squared plus 3 all real numbers? Yes. Is my outside all real numbers? Yes. So everything is all real numbers. Now we're going to do, this is the same notation right here. H, so is on the outside, so 2 times something minus 3. And then j of x is on the inside now, so square root of x minus 1. Well, I have a square root, so I need what's under the square root, aka x minus 1, to be greater than or equal to 0. So my domain is x greater than or equal to 1. Okay? J of h of x. Once again, we're just reversing the direction. So square root of something minus 1. And the something I'm plugging in is 2x minus 3. Once again, I have something under the square root. So all that stuff under the square root, I'm going to write on the top so I have a little bit more room. 2x minus 3 minus 1 needs to be greater than or equal to 0. So 2x needs to be greater than or equal to 4. So x needs to be greater than or equal to 2. F of h of x, and once again, how I know that this is composition and not multiplication is that the little O thing right here is not filled in. Okay, so F is my big fraction thing. So 1 over something plus 2. The something I'm plugging in is 2x minus 3. And for my final answer, you can just leave it as this hot mess that it is. You don't need to be simplifying. Okay, so my domain is that the denominator, 2x minus 3 plus 2, cannot be equal to 0. So I solve all that and get x cannot be equal to 1/2. F of g of x, I was so nice to you in this one. Not really. We're going to do, but we're not going to worry about domain. I'll tell you what it is, but. So x squared plus 3. Okay, I want you to think about in this one that when I square a real number, I'm always going to get a positive. So I'm never going to basically get 0 in the denominator. So this domain is actually all real numbers because there's not a way for me to get the bottom equal to 0 with real numbers. When I do h of x, that means you're going to do your normal structure, 2 of 2x minus 3, but then what you plug into it is still 2x minus 3. It's very meta, okay? And my domain there is all real numbers. Same sort of thing for g of x. We're doing something squared plus 3, and the something we're squaring is x squared plus 3, which is going to be all real numbers. So what we want to do if we're given values is you want to start with the inside piece and then work your way out. So h of 2, plug into h, 2 times 2 is 4, minus 1 is 1. So now I want to find g of 1. And when I plug 1 into g, 1 squared is 1, plus 3 is 4. So the next one, we have h of, plug 5 into j. 5 minus 1 is 4, square root of 4 is 2. And now we're going to plug 2 into h. 2 times 2 is 4, minus 3 is 1. And last, we're going to plug 1 into g. So when I plug 1 into g, I get 1 squared is 1, plus 3 is 4. And now I'm going to plug 4 back into g. So 4 squared is 16, plus 3 is 19. So that was function composition. And the last thing from that unit was function inverses. Function inverses. So my first step for inverses was to switch x and y. And then we're going to solve for y by using inverse operations. So we got really good in logs and exponentials with undoing the first part. So undoing the first part for this equation means that I'm going to subtract 1 and divide by 6. So we're going to do x minus 1 divide by 6 equals y minus 2 cubed. Okay, the next thing I need to do is undo my cube with a cube root. So I'm going to cube root that whole big fraction. And then hopefully we can see what our last step is. X minus 1 over 6 equals y minus 2. So my last step is to add the 2 over, and I get y equals cube root of x minus 1 over 6 plus 2. The one that gave you the most trouble was this one when I have an x in the top and the bottom. But our first step is the same, switch x and y. Then our next step is to multiply by the denominator. So I'm going to multiply by y minus 5 on both sides. Once we do that, we're going to distribute. So x, y minus 5x equals, now the right side has simplified to just the numerator. Our next step is to get all the y's on one side and everything that doesn't have a y on the other. So I'm going to leave xy, but subtract the 1y over, add the 5x over. Believe it or not, we're almost done at this point. The whole point of moving the y's on the same side is so that I can factor out the y, which would be left with x minus 1 equals 5x plus 2. And then we're going to divide by x minus 1, what I factored, on both sides. And I'm going to be really lazy right now and just circle that answer. Ding! All right. Last thing we did was proving that they're inverses. So for me to prove it, it means when I do f of g of x and g of f of x, I get out x. You can't just find the inverse of one and be like, oh, look, it's the other one. Yay! Okay. So 5, I'm going to do f of g of x first. 5 cube something minus 2, and now the something I'm going to plug in is right here, and we're going to see if it simplifies right. So order matters for this, and this is where I was picky about you showing your steps. So the first thing that's going to cancel here is my cubed and my cube root. So that's going to simplify to 5 times x plus 2 over 5 minus 2. Next step would be that the 5's cancel, and I get x plus 2 minus 2, so I do get out x. But I need to see those steps. You don't want to just kind of willy-nilly start crossing stuff out. That's not really how this works. If I do g of f of x, I'm going the other way. So I'm going to have big fractions. This is probably not big enough, but that's okay. And now I'm going to plug in f of x, which is 5x cubed minus 2, and then plus 2. So you also want to make sure you copy stuff down correctly, because that was another issue. So the first thing I would have is 2 minus 2. So then I'd have cube root of 5x cubed over 5. Then the 5's would reduce to 1. And I'm left with cube root of x cubed, which does give me x. So yes, these are inverses. And that's how we prove that they're inverses. We can also do it with lines. So this would be, f of g of x would be 6 times something minus 1. That something is this, so 1/6 x plus 1. This is where I continually have magic going on right here. So we get x plus 6 minus 1. I have a whole bunch of people just randomly bringing down that 1. No, we have to distribute, okay? I know why you're doing it, because you want it to be x, because you want it to be an inverse. But this one happens not to be an inverse. And as soon as one of these doesn't work, you can stop. So not inverses.